Hey, welcome to part 1 of 4 for 1-6 compound inequalities. So our essential question is, what are compound inequalities and how can their solutions be represented? Our target today is I can write and solve and graph compound inequalities. So in 1-5, we got introduced to inequalities, how to solve them, what happens when we divide by a negative number or multiply by a negative number, and then how to graph them on a number line. So that continues in this lesson. So in this first part A, the question is, how can you use inequalities to describe a set of numbers? So let's look at an example for a set. Please copy this onto your notes. So go ahead and draw yourself a horizontal number line. We're just going to put 0 here in the middle. And then over here, we're going to put value 2. And to the left of 0, we're going to put -3. We're going to have an open circle, a closed circle at -3 with an arrow going to the left. And then an open circle at the value of 2 with an arrow pointing to the right. So we're going to look at this graph and its solutions and what do they mean. So this graph shows the solution of two inequalities. The two inequalities form what we call a compound inequality, and a compound inequality is just made up of two or more inequalities. So we're going to look at each individual piece. So let's just look at this piece on this side. We're going to resketch that. So for that little piece, to see what it's representing, we have a closed circle at the value of -3, and then we're indicating all the solutions to the left of that -3. Because it includes the -3, since it is a closed circle, the inequality for this would be the x values that are less than or equal to a -3. If we look at the other side, which is this one over here, and we graph and represent that, go ahead and sketch yourself another number line. We're going to put our value of 2 with the open circle and all the values to the right of 2. That inequality would be x is greater than 2. And it's not equal to because it does not include the 2, it's just up to the 2. So the compound inequality that describes the original graph up above would be represented as the x values that are less than or equal to -3, or the x values that are greater than 2, because it does not include the values in between the -3 up to the 2. Let's look at a second example. So for B, go ahead and sketch another number line. On this one, I'm going to have a value of 1. I'll note 0 here. And then -4 over here. Above -4, we're going to put a closed circle, so it's going to include -4. Above the 1, we're going to put open circle, so it's up to the values of 1, but not including 1. But this time, we're going to indicate the in-between values. And what would that represent? So we're going to look at each section again. So if I look at this section here, and I want to graph just that inequality, I'm going to sketch another line underneath. It's identifying the value of -4 and all its values to the right of -4. So my inequality, if I just do that part, would be this, which is x can be greater than or equal to any value of -4. So x is greater than or equal to -4. Now, if I represent this side over here, let's go ahead and sketch just that part. I have a 1. It does not include 1, but up to 1. And it's all the values to the left of 1. So my inequality for that would be x is less than 1, but does not include 1. So to represent that as a compound inequality, because it's the in-between values, the compound inequality that describes the graph would be -4 less than or equal to x, and x is less than 1. So something that I've noticed students in the past have gotten a little confused with is, how is this the same as this? So inequalities can be read from left to right or right to left. If I read this, I am going to say x is greater than or equal to -4. Notice that now my variable and my constant flip sides, I have -4 less than or equal to x. So if I flip my variables with my constant, notice that it went from greater than or equal to, and then over here it's less than or equal to. Something important to notice is that the closed part, or the small point, is towards the -4 on either one. And the open part of the inequality is towards the variable x. So whether you read it right to left or left to right, they mean the same thing. You can also write it as, instead of using and, if you notice here, because the variable is on the right side for one inequality and the left on the other one, it could also be written as -4 is less than or equal to x, which is less than 1. And this will make more sense once we have more practice. Okay, I'm going to give you a compound inequality. I'll give you the graph, so please sketch it. And then your job is going to be to write a compound inequality that describes it. So let's go with example A. We're going to have a number line. I'm going to have a value here at -2. And then another one over here at 6. So this one will be open circle. And the 6 will be closed circle. And we're going to include all the values in between. And then for example B, for the try it, we're going to have a value here at -1 with an open circle. And a value over here at 3 with a closed circle. And the values in between. So go ahead and pause the video and give it a try. I will check in with you tomorrow to see how you did on this first part.